Whatever you want me to do. Oh my God.
I looked, I tried to put a decent one in again, but it was like side. It's like, no, you can sit here.
Two weeks in a row?
That's so weird. It's gotta be the same.
Like I'll say to my kids, sorry only gets us so far.
No, I just like it. You like it. You're about to fall.
Sorry. I get it.
Please make sure you come down and get a worksheet. Around the end.
Careful, she likes
Where at?
She's in a dark side. Over like that side, but you still have that. But I'm like, wait, I have sworn.
Whose are they?
I'm scared to talk this off here. But it's scary. Yeah, and she could be like, no.
If anyone has lost their L&M filter, Class A cigarettes, full pack, there's 20 of them just bought them. If you lost them, please come down and play. Anyone? Anyone?
I know you'll throw it though. What am I that you stole from a reading concession? This one I stole from Oh my God, that was so
Alright, we're going to get started with just a couple notes and then we'll dig into your sheet a little bit.
I think now would be an appropriate time to stop talking and pay attention to today's presentation on solution concentration.
starting a unit on solutions lately, various degrees, in different sections, different things so far. But one thing that we wanted to introduce today is a way of calculating the concentration of a solution in a way that's not necessarily tied to moles and molarity that we've done in the past. The reason being, there are a lot of places in your everyday lives, there are a lot of places, even in science classes, where molarity is not necessary, and it may be even confusing beyond what's sort of everyday. And so the good news is we're not going to go along the molarity, which you've already dealt with. There are a couple of questions on your sheet there. The first 6 are about molarity, but then after that we switch to the other kind. The other kind's a lot simpler than molarity, moles, and it's a lot more everyday. You see it in things all around you all the time already, whereas I suspect most of you never find anything in your everyday life that has anything to do with molarity on the side of it. Percentages is kind of the currency of everyday solutions. So you've already seen molarity, you've worked with molarity, for example, as this picture so humorously illustrates, 2 moles per liter of a solution. We've talked about this already, you've used molarity already, we'll be using this some more. But the idea is when we work with molarity, it's in moles per liter. And if we're giving you information about the mass of a solute or the volume of a solution or the number of moles involved, we can use this equation to kind of relate those things. And this isn't new. We've already used this back when we did stoichiometry in 3rd quarter. A lot. We did a lot of problems where molarity was involved. What volume of a 2 molar solution would be needed to react with 5.3 grams of calcium carbonate? Now you can figure it out from stoichiometry. So you've used molarity already, but look at the general structure. It's molarity equals the solute, which is the substance we're dissolving, over the volume of the solution in liters. So it's a 3-part kind of equation, where you can branch off or interrelate to grams of solute and milliliters of solution. It becomes sort of a little bit extended, but it's basically at its heart here in the black, a 3-part equation, molarity is moles over liters. What we're going to look at new then, at least new to this year, is percent concentration. So this is the one we want you to get down. I know one of my sections we talked about this briefly on Monday. The others is new too, so hang with me if you've got this already for just a couple minutes from other class. And then we'll be getting on to some problems with it. Percent concentration is something you'll find in everyday life. If you look at a bottle of something at home, if you look at a tube of toothpaste, you'll see there's a percentage on it. Most everyday products that you go to the store and buy, to get for your bathroom, for a cleaning product, for your garage, almost anything that's a solution will be illustrating what percentages of each component that's important are in it. And we'll be working with this in a couple different places in everyday stuff in our labs coming up. Right? But percent concentration is everyday useful because it's something we're already familiar with. We know what percentages are because we shop and we wait until things are 30% off or something. We know what that means. So percent is sort of a natural thing where molarity at first isn't as familiar as percentages will be. So good news, you've already worked with percentages enough and you know about this. If I want to know the percent of our student body that's sophomores, I could take the sophomores and divide by the total times 100, I have a percent sophomores. Well, that's how percents always work. It's something we're interested in divided by a total of which that is a part times 100. Right? So solute over solution times 100, sophomores over student body times 100, whatever it might be. Except if you look at that equation, there aren't any units in it. So we have moles, liters here, and here we've got solute and solution with no units in it. The reason is there's different ways of putting different units in those positions. On the top, your solute can be expressed in either grams or milliliters. Now, it could be in other things, but most common solutions in chemistry will be giving your solute in grams of solute or milliliters of solute. The big difference being when we're working with solids, it's usually a little easier to work with masses. When we're working with liquids as our solute, it's usually easier to measure in milliliters of volume. Gases are a little shaky when it comes to this, because we're used to thinking about the volume of a gas a little differently than the volume of a solution. And we'll see with gases, usually we're going to work with gases in mass and grams. So you can put grams or milliliters in the top, depending on how you need to use the equation. And on the bottom, we can use the same thing. So you might work with grams and milliliters in the numerator, you might work with grams and milliliters in the denominator. That gives us a couple different ways to set up percent concentration using various combinations of those two babies, top and bottom, top and bottom. You think about how many different ways you can combine those options, and you come up with 4. We only utilize 3 in a regular way. The 4th one's just not real functional. So there's 3 ways we can use these. I'm just going to show them to you all at once. So they're there at the bottom. If we use grams on the top and grams on the bottom, we get a percentage. But how we label it will tell us what we used. So if I take a mass of solute divided by a mass in grams of solution times 100, I get a percentage. And it's percentage with an M over N. We show the label on the percentage with a mass on the top and a mass on the bottom. Mass over mass. And we would sort of verbalize that if we were to say it. Percent mass by mass. Because we divided mass by mass. So the red one is if we use grams on the top and the bottom. In the green, we see if we use grams on the top for the mass of our solute, and then we mix that into a certain volume of solution. That's actually very common. Right? So mass over volume. Before you can come to the eye, we get a sheet. Okay. Grab a sheet. Grams over milliliters. Mass over volume. Percent M over V. Okay. That's going to be pretty common, but the M again means I put a mass on the top, the V means I put a volume on the bottom. Notice what we don't do is put grams over milliliters in our label. And it's because when we find a percentage, it's useful beyond just grams and milliliters. We want to specify there that we measured something's mass on the top, volume on the bottom. And the last one is a combination that's also very common. Where we take a volume and divide it by a volume, we would see units of milliliters divided by units of milliliters. And we show a label as a percent V over V. Or percent volume by volume. We divided volume by volume, and that's our label there. So when you label your answers and you're seeing information given to you in percentages, be cognizant of what combination of units you've used, M's and V's. And be aware that each of those represents something slightly different, but in the end they all mean percentages in a kind of similar related way. And they all have different usefulnesses in different places. I challenged my class the other day when we talked about this, and I would pass it on to all of you too. Go home, when you look at your stuff around your house, and look at the labels on them and see if you can't find percentages, but also see if you don't find something specific like MV or VV. There's probably not a lot of MNs. If you find something labeled around your home that says M over M as a label on a piece of rocks, take a picture, read it. And most solutions you're going to find will give you something to do with mass, volume, or volume. So those are just kind of the 2 most common ones that there are. So I pulled up a label here. This is a label off of a bottle of iodine tincture. Now iodine is used for any number of things, usually disinfectants. If you've ever had like a blood draw, or if you've given blood back in the day, they used to scrub the inside of your elbow with iodine. Now they use alcohol, but iodine is a great disinfectant. And they have these tinctures of iodine. There's solutions of iodine in alcohol and mixed with water to be used in everyday stuff. So you see your iodine tincture. A couple things there. You see at the top it says 2% mild. So this is a relatively low concentration of iodine. And then it says alcohol 47%. So there's already a couple percentages right there. This solution contains 2% of something and 47% of alcohol. And then if I turn my head slightly, or maybe you can just do it with your eyes without having to turn your head, you see there on the drug facts it says iodine 2%, sodium iodide 2.4%, alcohol 47%. So you got all kinds of percentage information there. Those kinds of labels can be then sort of dissected. We can figure out exactly how much is in a bottle of this. And if we're going to go in the lab and work with it, we're going to see if we actually improve some of these concentrations through various experiments, kind of working out experiments to figure out exactly how much is there according to what we measure. And we'll see if what they're shipping out to us in these bottles is accurate or not. We're going to be working, I think most of our classes, we're going to be working with analyzing gasoline samples. See if there's a concentration on that label at the pump that says such and such. If that comes out to be true, when I go test it in the lab, or if the percentages they're claiming are in there aren't good, bad, or in between, if it's not true, we want to know why. Okay, so let's try a problem or two off your page. Mr. Mitchell's going to try a problem off your page.
Let's do it. For those of you guys who don't know the backstory, Mr. Blatt had a pad that he likes to write on, and I have a lot of anxiety about writing on that pad. And I didn't like to do it because I didn't feel like I was very good at it. It looked terrible when I did it. And I was afraid people were laughing at me in the audience, so I wouldn't do it. Kind of like yesterday you saw the speaker. I didn't have the confidence to sit here and do this. So Mr. Black, by being a great husband, got a new gift. His wife bought him, what do you call it? What is it called? Surface. Yeah. Microsoft Surface. So now Mr. Black got a new toy. I haven't been able to use this toy, but I asked him today if I could attempt to do these problems for you with his Microsoft Surface. So that is the backstory on why I'm attempting to do this today. In a true large group chemistry fashion, we're trying this for the first time in front of an audience. So bear with me.
This is the educational equivalent of Mr. Mitchell's never been comfortable driving, say, like a stick shift truck, and I got an automatic, now he wants to try it, because he knows it's a little easier.
And we always get mad because we say, why did we try this for the first time in front of a large group when things go bad? So here we are again, trying something again for the first time in front of a large group. It's like
We're going to look at question 7 because it's the first one that's percent concentration, the first 6 are molarity. We'll probably come back to those as needed in our small group classes. We want to get you percents today, so start on 7.
Can I do a gram volume, a mass volume calculation? Is it appropriate to do that here? How do we specify what the concentration is in the end? So I can start to do my percent concentration calculation with grams and with milliliters. So I'm just going to start with my 25.0 grams, or whatever my solute is, divided by my 180.0 milliliters of solution. And when I calculate this, I want it to be in a percentage. Now, a lot of you equate percentages to maybe grades on a test. So if you took a test and there was 180 points, and you got 25 of those points, would you consider your percentage to be quite low? Probably. So you might want to say to yourself, this is probably going to be a pretty low percentage. This looks like something I would have gotten in an organic chem test in college, 25 out of 180. So if I wanted to find my percentage then, 25 divided by 180, I get 13.9%. Is this where the story ends here? What do I want to add after that? Mass volume. Agreed? We pulled it out. Now, let's say that we know the percentage. Mass of solute is 17.5% mass-to-mass solution. It has a mass of 350 grams. What is the mass of the solute? Now, in this case, we know the percentage. So we can set that as our percentage, 17.5% equals, we don't know the mass of the solute. So we'll set that as X. We know the solution mass of 350.0 grams, and it's times 100 because it's a percent. Probably the quickest way to solve this is just use your times 100, so divide by 100, divide by 100, 0.175 equals X over 350.0. A lot of times when I see percentages, I'll just set them as decimals right away, instead of having to do the divide by 100. It's probably quicker for you to understand that 17.5% is 0.175. Now to solve for X here, it's just simple algebra at this point. Multiply by my 350. Multiply by my 350. The mass of my solute in this situation, 350 times 0.175. 6.3 grams. Solve. Mr. Black, this is spectacular.
This feels a little bit like when I thought I could drive my Corvette and I let Mitchell drive it, and he like fully showed me that I didn't drive it at all. This is just beautiful. It's like watching someone who's like finding harmony with their device down there.
It's like, for those of you guys that don't know, I used to be a carpenter. So my wife, I was asking, she says, husband, how come you're such a great carpenter? I say, because I have great tools. So without the right tools, I can't be a great carpenter. How do I do great finish work? I have a nice saw. If I had a handsaw, what would my carpentry look like? It would look like garbage. You have to have the right tools, and today, I have the right tool. Yes, I was. 7 years of my life. I still and I was an umpire. I'm the man of many hats. We want to try a couple on our own?
Are you serious?
Let's do, one more? Which one do you want? Request? 5. What number? 5? Now, 5 is a molarity. You want to go back to molarity?
No.
14 it is. Do it 14. I'll go back and do number 1 molarity. Now, what about sodium hypochlorite? Would be used to prepare 2 liters of a 3.5 volume. Now, if it's a volume, what's my answer unit going to be? Well, my volume's in milliliters. What's my answer going to be? Milliliters. Very good. So if I'm going to set this up, I'm just going to go ahead and start with my 0.035 is my percentage. That's going to be equal to my solute, which we don't know. My solvent is 2 liters. Agreed? Solve for X here, multiply by your 2.00. So 2.00 times 0.35 is 0.070 liters, which will give you 70 milliliters.
If the question doesn't ask for a particular unit of milliliters or liters, then really either one's okay. As long as you label yours with the proper unit, it won't matter which one you choose. As you're figuring out real quick probably with these, it's really just manipulating simple algebra to find x, but you gotta know where x is. And that's kind of a big deal.
Let's do one that mixes up the x here a little bit. I'm going to move to number 10. Because I know there's a few people that struggle with the way that number 10 was set up when we're doing some of our K2 expressions. What is a volume of 30% volume per volume isopropanol solution that contains 23.5 milliliters of solute? So my percentage here, 0.30. Now, my solute is 23.5 mils. We don't know the volume of the solution, so we're going to make that X. Now, there is some confusion on how to solve for X. There's a few ways you can go about doing it. I can set it up in a proportion and cross multiply and divide. My personal way of doing this, I always want to make sure that the variable that I'm solving for is on the top of the equation. So I typically take X and I put it on top. What you do to one side, you do to the other. So now to solve for X, I'm just going to divide by 0.30. 0.30. So then the X is 23.5 divided by 0.30. X is equal to 78.3 milliliters. That's one way to do it. I can also set it up like this. set it up as a proportion. How do I solve for x now? Cross multiply and divide. 23.5 divided by 0.30. I could also do this, because I see a lot of people that just want to divide by 23.5. You can do that, but you're solving for the inverse of x. So this is equal to 1 over x. So you got to take that, find the inverse. So there's a few ways you can go about doing this. I see people just want to isolate x, but they leave x on the bottom. What you're solving for is the inverse of x. It's okay if you do that, but you got to realize the answer you got is the inverse of x. So you got to find the inverse of that number.
The good news for all of you who struggled with square roots in our last topic is there's no square roots here, so at least you don't have to worry about that.
If I do this, x is 78.3. X is 78.3. Same answer for all of them. How you choose to do the algebra, I haven't been your algebra teacher, so I'm not 100% sure how you learn the algebra. There's a few ways to do it. I know how I do it, the easiest way for me to do it. The easiest way for me to do it is the easiest way for you to do it. Again. But in all of them, you're solving for x. Somebody was trying to shout out a request, who was it?
Number 1.
11.
Before I jump over to polarity, I'm going to do 11 because I'm going to have to switch gears when I get to polarity. So I'm going to do 11 quick. And then we'll move into the ones prior to 1 through 6. Mr. Bluff, you never get to do this again.
Yield.
This is fun. Calculate the percent composition for a solution with 27.6 milliliters of methanol and 240 milliliters of solution. So what do you do if it's two solutions? It's one solution. Read it. Calculate the percent composition for a solution with 27.6 milliliters of methanol, 240 mils of the solution. Which one is the solute here? The methanol. The methanol is the solution. So, for this one, I just take my 27.6 mils over 240.0. Times 100. Again, looks like one of my OPM scores. 11.5%. What's important to write after this? Volume to volume.
If you're ever confused about what goes top, what goes bottom, right? The number on the top cannot be a greater volume than the number on the bottom. It's only part of the total.
I was going to say that, but I hate saying never.
Yeah, with volumes it can't be.
Yeah.
Right. So.
Mass is good. Well, yeah. I don't know.
It could be.
Does that make sense? If you have two volumes, smaller ones all the time. I want to say, somebody asked for number 4. Now, I don't know why, but polarity has escaped a lot of people in chemistry this year. And I don't think we give ourselves enough credit for what this little letter right here actually means. That capital M means moles per liter. It's your conversion factor, so to speak. Okay? So at number 4, when it reads, what volume of 0.2 molar solution could be prepared using 100 grams of NaCl with enough distilled water? We're looking for liters. What else do we have to know? Do we know the conversion factor? We don't. We know the conversion factor is 0.200 moles per liter. What else do we know? We know grams. Can we convert grams to moles? Yes. Once we have an answer in moles, can we convert moles to liters if we know the conversion factor of moles per liter? Yep. Mrs. Arnold can do it. Can you? Yes. Now, in this one, I'm going to start with my 100 grams of NaCl.
That's a 100.0
.0. Now,
Big fix there.
1 mole of NaCl is 58.5 grams.
You just did the math for you.
NaCl. Grams are gone. Are they asking for an answer of moles? No. They're asking for an answer in liters. Do we know what conversion factor of moles to liters here? We do. We know that in 1 liter of solution, there are 0.20 mole NaCl. Agreed?
C.
8.55 liters. Mr. Glenn did this a little bit differently on his answer key, and I'll show you what he did. He hit his equal key right here, and he determined that we have 1.71 mole NaCl. Where molarity is moles per liter, he took his molarity of 0.20 is moles of 1.71 in salt per liter. Is the math the same here? How would we solve for X? You could set up equality, solve for X, cross multiply and divide. You could, try to erase that. Oh yeah. I could get X on top, divide by 0.20. Any way you slice it. .55 liters. Molarity is your ratio of moles per liter. I'm assuming that when you didn't listen to me during that last little section, you understand molarity completely. I know personally some kids that don't. I hope you were paying attention. Any other requests? 15? 1-5. You guys know that the more I do, the less you have to do at home. You're very smart. What amount of water would be used to prepare 500 grams of a 0.75% mass-to-mass salt solution? Oh, this isn't good. What amount of water? Mass to mass. Now, we're going to make the solution. The percent is what? What's the percent? What's that number as a decimal? 0.00750. That's the percent as a decimal. Now, the total is 500 grams. So the solute then, not too tough, 0.0075 times 500 is 3.75 grams of that salt. Agreed? It doesn't ask for the mass of the salt, though, does it? No. It asks for what? So how do we figure out how much water we're going to put in there? We're putting 3.75 grams of salt, and the total mass is 500. 500 grams total, minus 3.75 grams for the salt, is going to give you gram H2O. Here we just do simple subtraction and find the difference. 496.25 grams H2O.
What Mr. Mitchell's taking advantage of, and like he hinted at here, is something we haven't had to do in any of the other problems. And he's finding for the solvent. And this percent concentration equation that we started the day with doesn't have solvent in it explicitly, but it's hiding in the solution. So if you know that solution equals solute plus solvent, which is just like basic definition of solution, then if you know the solution and you know the solute, take it out and what's left is your solvent. That's what he did on that one. Look at trickiest one. So if you recognize 15 is what he should do, you made a great choice. I gotta say, watching Mr. Mitchell with my circus was wonderful, but it's kind of like watching my wife dance with like her brother who's a really good swing dancer, and I'm not. Like, yeah, he can dance with her, and like she can enjoy all that, but at the end of the night, she's still coming home with me. You guys have a great day. Pour the money, buy Mr. Mitchell a Corvette. I mean, a circus and a Corvette.
Personally, I think cheerleaders shouldn't have to sell stuff to raise money. They should just get a portion of all the different sports as money. Since you guys get to support them all the time and never get any love. That's my belief. But, way to go.
At the end of the day, yeah, they kind of lost.
You're starting to recognize when you understand.
How many kids are sitting out there and they say, oh gosh, I don't know how to do this?
They were missing labels. One guy saw it, they were missing labels.
Were they?
You caught on that really first one a couple times out. Excellent.
Taking these 6 out. Wow.
Are they cigarettes or are they white tobacco?
They what?
Are they cigarettes or white tobacco? Marijuana.
It's not marijuana. No, they're 6.
Just curious. Anything else you need, Mr. Black?
Nope.
Hit the stream as I leave?
It's not the stream. Yeah, I haven't done that.
Okay. Okay, I would take care of it if I could find my keys. Oh, they're there. Found them.